All right, let's talk about something that's about to completely change the game for software developers. This isn't just about another AI assistant. No, we are diving headfirst into a whole new way of building things. This is the era of the AI agent.
Just let that sink in for a moment. We're not talking about asking it to write a little function for you. We are talking about an AI partner that can look at your entire project and get it, truly get it, faster and more deeply than you, the human who built it. That's the future we're stepping into.
So first things first, we got to make sure we're all speaking the same language. We've all gotten pretty used to what we call AI coding, right? That back and forth chat where you kind of nudge the AI until it spits out the code you want. Well, agentic coding is a whole different beast. It's like the difference between asking for a single sentence versus handing over a 2-page outline and saying, go write the entire novel and edit it and proofread it. It's a massive leap.
Okay, so let's really dig into what this shift means. Because this isn't just a shiny new feature or a tool that's, 10% better. This is a fundamental change in our relationship with computers, in how we as engineers actually solve problems. And here is the absolute core of it. Our workflow is about to get turned on its head. Your job is no longer to be the person typing every single line of code. Instead, you become the architect who designs the blueprint and then hands it off to a crew that can build the whole thing. You stop prompting for code, you start commanding a complete, self-validating result.
But here's the catch. To make this work, you can't just throw it at any old messy project. Nope, your code base itself has to, well, AI ready. And that means you have to lay a new kind of foundation, one that allows an AI agent to instantly understand everything it needs to know.
And this foundation, it really comes down to 3 key directories. Think of it like this. First, you have your AI docs. This is the knowledge, the library. Second, you've got your specs. These are the blueprints, the master plan. And third, Agentic DIRs. This is the tool belt, packed with all your specialized commands and agents.
So let's break down the why here. Your AI docs give the agent all the background context on your project. The specs give it the explicit plan of what to build, and the Agentic DIRs give it the specific tools to do the job. When you put these 3 together, you create a system where the AI never has to guess what you mean, and you never have to repeat yourself. It's beautiful.
Now, this structure leads us to the single most important idea that unlocks all of this productivity. Seriously, if you only remember one thing from this whole explainer, make it this. The quality of your plan is the quality of your agent's work.
That's it. That's the mantra. Write it down. The plan is the prompt. Great planning is now great prompting. The more detailed and thought out your spec file is, the bigger and more complex the task you can just hand off to your agent. We have to stop thinking in tiny iterative prompts and start thinking in comprehensive plans.
And this is the kind of insane leverage we're talking about. A really well-crafted plan, maybe 1,000 tokens, a few pages of text, can expand into an entire functioning code base. You're not writing code anymore, not really. You're writing the master blueprint for the whole building and letting the AI handle the construction.
This whole workflow just flips the old way on its head. You start with a simple brief. Then the AI. It reads your whole AI-ready code base and drafts a super detailed plan for you. Your job becomes a reviewer, a curator. You look at the plan, you give it the thumbs up, and then you say go, and the AI executes it. Okay, so you have your master plan. But what happens when the job is just too big or too complex for one agent? Well, this is where you stop being just a planner and you start becoming a commander. You start delegating tasks to a whole fleet of specialized subagents.
Now, the flow of information here is absolutely critical to get right. You command one primary agent. Think of it as your project manager. It then looks at the plan and delegates specific tasks to specialized subagents. They do their work, report back to the primary agent, which then pulls everything together and gives the final result to you. You manage the manager.
And this brings us to the #1 mistake that engineers make when they first try this. The file that defines a subagent. That is not a command you're giving it. It's the subagent's system prompt. It's its personality, its core identity, its entire reason for existing. If you get this wrong, your whole system just falls apart.
The second huge pitfall is forgetting who the subagent is talking to. It is not reporting back to you, the human.
It's reporting to the primary agent, another AI. This means your system prompt for that subagent has to tell it exactly how to format its response so that another machine can understand it perfectly. If you forget this, you're just going to get pure chaos.
So you've got this fleet of agents running around doing all this complex work. How on earth do you keep it all from going off the rails? You need a control panel, and in modern agentic systems like the Claude Code example we're looking at, you get this control through a system of what are called hooks. Hooks are just simple but incredibly powerful. Scripts that you set up to fire at very specific moments in your agent's process. They give you total deterministic control. You can monitor what they're doing, you can steer them, you can even block them. This is how you build multi-agent systems that are robust, observable, and, most importantly, safe.
You can essentially tap into 5 key moments. Pre-tool fires right before an agent uses a tool, letting you check if it's a safe command. Post-tool fires right after, so you can log what just happened. Notify is for when the agent needs to ask for your permission. And the stop hooks are just a confirmation when a subtask or the main task is totally done.
And this is where it gets really cool. A pre-tool hook can literally save your bacon by catching a dangerous command like rm-rf before it ever runs. A post-tool hook can log every single action to a dashboard, giving you perfect observability. You can even use a stop hook to trigger a text-to-speech API, literally giving your agent a voice to tell you when its work is finished.
So let's zoom all the way out. We've got these AI-ready code bases. We have plans that act as massive prompts, and we've got fleets of controllable agents. What does this all add up to for us, for the engineering profession?
Well, it means the skill gap between engineers is about to become a chasm. Engineers who master these agentic systems are going to unlock a kind of compute advantage that will make them ridiculously productive. And those who stick to the old way, the iterative back-and-forth prompting, they're going to get left in the dust. It's that simple.
Which brings us to the final and most important question. When these systems become truly great at planning, building, and testing software, what is our new role? Our job has to evolve. We have to move from being the builders to being the architects, from being the coders to being the conductors of an AI orchestra. The question isn't if this change is coming, it's how are you going to adapt?